We are given this matrix 2 by 2 matrix P equals to 1, 0, half and 1. Then what is P power 50? Clearly in the options we are given 25, we are given 50. All other numbers are 1, 0, 1s only, right? 25, 50 and again 50 and 25. Clearly there is a pattern, right? P power 50, the pattern is 50 is related to 50 as n equals to n, or 50 by 2 is 25. That's the pattern. Right, let us try to identify this pattern by doing p square, p power 4, etc. Right, then we should be able to find out how is it looking. Then p power 50 we can easily estimate. Right, if you do p square, that is nothing but p into p, then this first row into first column, that is 1 into 1 plus 0 into half, that is 1. 1 into 0 plus 1 into 0 plus 0 into 1, that is 0. Half into 1, half plus half into 1, which is half plus half, which is 1. Half into 0 plus 1 into 1, which is 1. That is p square. Right. Now what is p power 4? This matrix again into the same matrix, that is this. Right, which if you do p power 4, we are getting 1, 0, 2, 1. And if you want to do p cube, what we do? That is nothing but p square into p. That is p square into our original p, we are getting 1, 0, 3 by 2, 1. Clearly we can see a pattern, right? So this 1, 0, 1, this is static, this is not moving, this is not changing. But this fourth element, this one, the second row, first column, A21, right? P21, that is actually nothing but in this case it is 3 by 2, in this case it is 4 by 2. In the case of 2, it is 2 by 2, that is 1. In the case of 1, it is 1 by 2, right? So we can clearly see P power n is looking like 1, 0, n by 2 and 1. Right. Now, if you want to prove this also, because we have verified for 2, 3, 4 times, it doesn't mean it will satisfy for everything. Ideally, we should be able to prove this also. How do we prove this? So, for example, if we get p power n equals to 1, 0, n by 2, 1, if you are claiming this, then using a mathematical induction, if you multiply this again with 1, 0, half 1, right, then we should get p power n plus 1, right? P power n plus 1, if we claim that p power n is this, and then p power n plus 1 will become this into this, which is nothing but this multiplied by this, and this multiplied by this, and this multiplied by this, and this multiplied by this. Okay, let us try to verify only this element, right? That is the 2, 1 element. That is n by 2 into this 1 plus 1 into 1 by 2, which is nothing but half into n plus 1, right? This element is n plus 1 by 2, which is what we wanted to prove, right? P power n plus 1 is again the same matrix, n is replaced by n plus 1. So hence proved that by mathematical induction, if p power n is this, and then p power n plus 1 is 1, 0, n plus 1 by 2, at the same time, this this relation is satisfied for p equals to 1, p equals to n equals to 1, n equals to 2, n equals to 3, etc. etc. So by mathematical induction, because it is valid for one or two cases, and it is valid for the general case. That is for the case when n equals to 2, n plus 1 is also true. So by mathematical induction, we can say that this is the general result. Now, when n equals to 50, obviously this becomes n by 2, which is 25. So this is the correct answer. This is the correct answer. Right.